Hello and welcome to another tutorial from Mike Dolan Games. Today we're going to continue our series on creating a space combat sim in Unreal Engine. So today we're going to look at one type of flight control basically for a space combat simulator, and this one is based on Freelancer. So it's a mouse movement where the ship basically chases the mouse position on the screen. And we're going to do this tutorial probably in two parts. The first part will be just getting the mouse and ship to be in sync and move, so the control portion. And then the second part will look at this, this UI, creating the crosshair and the arrow feature to show kind of like how fast or how much farther we're moving. Let's get started. Before we get started though, please like and subscribe. All right, thanks a lot. All right, so first step is if you're following along, you can either open up one of your previous projects that we were working on, or just open up a new flying example template project. Okay, so this is the flying example template project out of the box. We just have our ship that flies around. Okay, so no changes have been made here to this. And we're only showing the mouse steering portion, so we're not going to get into throttles or how one would make the ship go faster. We can cover that in a future thing. So let's get started just adding this new control scheme. So the first thing we're going to do is we're going to open up the FlyingPawn. Now, if you are creating your own full game, you might want to take this information and kind of create your own FlyingPawn, but for the purposes of this tutorial, we're just going to kind of like modify this one to get us all started. Okay, so in the FlyingPawn blueprint, we have a section here that's all based on the event tick. Okay, and this is kind of where all of the motion gets added. So when the controls are kind of like tracked via events, and then they're added to different variables on the side here. And so the current method for the flying blueprint is they take all the different pitch, yaw, and rolls that are calculated from the WS and D keys, and then they make a rotator and add the actor location rotation. So we're actually going to just scrap all of this and delete it. So once we get rid of that, the controls for turning won't work anymore, okay? But we're going to modify it, and we'll add on here and create our own rotation section. So what we're going to do is make it so that the ship follows the mouse. Okay, so the first thing we're going to do is we are going to get a player controller. So right-click, get player controller. All right, once we have that, we can get the mouse. So we're going to do a convert mouse location to world space. Okay, so in order to actually get the mouse, you need a player controller to find it. So now we have this. We have a world location, we have world direction, and I think this is just a Boolean to say that we found a mouse. Okay, so what we want to do is find the mouse on the screen, and then we want to create like a look rotation so that we can turn our ship towards it. So to do that, we are going to also get our actor location. So just look for get actor location. All right, and this will get the location of our flying pawn. All right, and then we're going to do a find look at rotation. Find look at rotation. All right, so this takes a start value and a target. Okay, so we're going to just plug the actor location into the start, because that's our like where our ship is, and then the bottom part is the mouse, but we have to do a few things to kind of convert a little bit here. So what we're going to do is we're going to project where the mouse is out into the screen a little bit, so it's off in the distance, because it's going to be kind of like the depth of the mouse position is at like 0. So we're going to take the direction and just multiply it by like 500. You can play around with this. This is just a number that I thought was fine. So we're basically saying 500 whatever units into the distance, that's where we're kind of aiming our ship, okay? And then off of the world location for the mouse, we're going to add. And we're going to do a vector plus vector, all right? And then we're going to plug in our multiplication one here. So now we're just basically adding some projection onto the location. So now we're pushing the location out into the world a little bit further. So that's all we're doing there. And then we plug that into the target. So now we have our lookout rotation. We know where we want to turn our ship towards, okay? And from there, what I'm going to do is I'm going to pull off of the return value for the find look rotation, and I'm going to break the rotator down. Okay, so now I have a X, Y, and Z, so pitch and yaw and roll. We're going to ignore the roll, and we're going to make a new rotator here. So just type in make rotator, and we're just going to transfer over the pitch and the yaw. All right. Okay, and from this, we are going to come up with like an interpolation, basically, between where our current rotation is at and where we want to be. So to do that, we need to get actor rotation, and we're going to do R interp, and we'll do R interp 2, and in the top, we'll pull the actor's current rotation, and then the rotator will be our target. All right, and then in here we're going to add so the delta time, I just put 0.5 for this, and then remember this is happening on tick, so and then the speed I have is 0.5, and I think if you use this speed thing, you can actually slow down or speed up how fast the ship rotates. So if you have like a bigger ship and you want to make it slower to rotate, you can do that. Okay, and then from here, once we have our interpolation, we're going to pull this return value out, and we're going to set actor rotation. Okay, so now we're taking that interpolation and we're setting our actor's rotation here. All right, so once we have that, and excuse the mess here, but we're just gonna, and you know, I would probably want to like pull this all into its own function, but right now, just for this, we're gonna leave it the way it is. So we're taking the add actor local offset, so basically where the event tick comes out here, where we deleted the previous rotation, and we're just gonna move that. We're just gonna connect right all the way to our set actor rotation. And so all of this calculation is happening, and basically we're just going to get this. We're going to set the actor rotation. So we've basically replaced the rotation that was here before. Okay, and then once we have that, we basically have our mouse turning. So let's compile and save. If we go back to our map now and press play, you'll see I've got my mouse cursor on the screen, and if I put it right in the center as best I can, we kind of won't turn. But if I go to the right, slowly it will start turning. And if I move it farther, it's trying to catch up, so it's moving faster and faster and faster. All right, until we get to kind of the maximum on the side of the screen. You can do the other way, you can do up, you can do down. Now, one of the issues that we have right now is if the user clicks on the screen, we lose our mouse. So we don't get to see where our mouse is. But for the most part, we've got this pretty much set up. Okay. So the next thing that would be helpful is having a like a dead zone for the mouse. You might want to have one in there. Basically, it's difficult to slow down the turning if you don't have like a dead zone in there. The bigger the dead zone, though, the harder it will be to kind of finesse your turning. So basically, you could stop here, and you have the mouse chasing, the ship chasing the mouse, and you've got the basics of the control set up. But we can also add a dead zone. So the dead zone calculation is also, there's a piece of it that's also useful for our UI. So I'm going to create it here, and remember when we get to the next video that if you skipped over or something like that, you got to come back to look at this. So what I'm going to create is a function that gets the mouse location, but it kind of like resets it so it's an offset. So the mouse, so the center of the screen becomes kind of like the 0, 0 coordinate, and then any offset from that 0, 0 center kind of tells us that the mouse is away from our dead zone. And then we can create a we can just create kind of some greater than math to determine like how far away we are from the center. And if we're far enough away from the center, then we'll allow the movement, and if not, we won't. So so in order to accomplish this, I create actually a function library, because I'm going to use this in multiple places. So I'm going to create a new folder, and I'm just going to call this game. It's good to have your own folder for your game content, and then actually organize your game content into other folders. I'm just going to create a content folder right now for this. Okay, so you're going to right click, you're going to go to blueprints, and we're going to create a blueprint function library. And I'm going to call this BPF or BPFL. I don't know what the official epic prefix for this is, but this is the blueprint function library, and I'm just going to call this mouse stuff. Okay, so if we open this up, it will automatically create a new function up here in the corner. And this is a library, so you can create a bunch of related functions, and then these blueprint functions can be used in other blueprints across your game. So the reason we're doing it here is because we're going to have the same logic in our FlyingPawn as we will in our UI in order to create some of the fancy UI stuff that I was showing earlier. So we're going to call this function get mouse position from center. Okay, and I'm pretty sure that's what this does. And but anyway, I like giving my stuff verbose names so I know what I'm trying to do. Okay, so how do we get the mouse position from the center? All right, to do that, we are going to drag off here, and we're going to get mouse position. And we're not going to call ourselves, we're going to get mouse position on the viewport. Now this is going to get our XY coordinates in 2D of the viewport. Now one of the problems with our viewport is it's set up so that the top left corner is 0, 0, and the bottom left corner is whatever the max length and width are of our viewport. I don't know about you, but when I think about math, I think about the XY coordinate of 0, 0 being in the bottom left. And when you're dealing with things like circles or what we're about to do, where we're trying to create a dead zone in the center, you think about the graph being in the center as 0, 0, and then anything to the left is negative, anything to the right is positive, above, upwards is positive, and downwards is negative. So our viewport does not give us the kind of the correct position, right? So we need to create some kind of offset math to create this. So we're going to get the viewport, but then we're going to convert it into our center stuff. So to do that, and I'm just going to actually pull this off right now and create a return node. So we're going to add return node, so we just type in return node. So you can have functions with returns. If you compile and save, you should be able to add outputs, and we're just going to add, the first one's going to be mouse x, and we'll set it as a float, and then we'll add a second one, and that will already automatically be a float, and we'll call this mouse y. All right, and these are going to be our mouse x and y positions that come from our math here. So once we get our viewport, we're going to have to do a few things to convert it. Okay, so the first thing we're going to do is we're going to get the center of the viewport. So how do we do that? Well, we say get viewport size. All right. So if you have an 800 by 600 screen, that's going to be what is returned here, basically. And then we're going to search for division, and we're going to divide the vector 2 by a float, and we're going to divide it by 2. Okay, that will get us halfway across the screen, right? I don't know why this doesn't. It drives me crazy that it's at an angle. Okay, once we do that, we're now able to kind of do some math around our viewport to get it. So we have our halfway. Okay, and the next piece we're going to do, I guess the easiest piece is the x value. So we're going to take the return value of the get mouse position, and we're going to split it. So now we have x and y. And we're going to pull off the x, and we are going to get a subtract, and we're going to subtract float from float. Okay, and actually this is in the wrong one, so I'm going to alt click it, and then I'm going to put the x on the bottom here. Okay, and then I'm going to take what we get from the halfway mark, and I'm going to put it up here. So we have to split this struct. Okay, now the halfway x, I'm going to drag it up here, and so now I'm going to say halfway across the screen and subtract it by whatever our current mouse value is. Okay, and then the last piece for x, and I forget why this is a quirk, but I need to multiply this by -1. So we're going to multiply the float by a float and -1, and then plug it into our return values. Okay, I forget exactly why, but I think it has to do with the fact that once we get on one side of the center mark, if we go, we have to multiply by negative because I think it's flipped or something. Anyway, so that's the x value. So that will get us a position kind of where the center of the screen is 0, 0, and now x will either be negative if it's on the left-hand side and positive if it's on the right-hand side. That's the main thing you need to know. Okay, so y is a little bit more complicated. So to get y, and I'm going to pull this stuff back actually a little bit just to kind of keep our thing here. To get y, we have to get the viewport size again. All right. And with this one, we're actually going to break the struct pin because we're going to use just the y value for this one. All right. And then we're going to pull this return y from the viewport size. So now we have the whole viewport. And we're going to press subtract. We're going to subtract a float from a float. And we're going to pull this one in here. So from the mouse position on viewport, we're going to plug that into the bottom of the subtraction. So now we're subtracting the mouse position from the total viewport y size. Okay. And then we are pulling out from here, and we're going to do another subtraction. And now we are going to subtract. Oh, and once again, this is in the wrong spot. So we're going to put this in the bottom. And then we're going to pull off from the midpoint here and do that here. So now we're subtracting from the center of the screen, or half of the screen width. We're subtracting our viewport size subtracted from the mouse position. Okay, so basically what's happening here is we're kind of getting a, like, how far away from 0 are we? And that's kind of what this is doing to get that y value. All right, and this one doesn't need any type of multiplication. The integers are correct on this one. All right, and we're just going to drag off this and plug it into the mouse y return. All right, and that is our function. So I can zoom out a little for you if you need to see it again. All right, okay. So once we have this, we now have kind of our mouse coordinates based on a 0, 0 center line for the graph. So I'm compiling and saving this. Okay. Now if I go back into the FlyingPawn, I'm going to create a little branch here. To do that, you can just, I think it's hold down the B on the keyboard and click, and that will create a branch. Okay. And we're going to actually plug the true in here, and then we're going to kill this connector. And we're going to go back to our node here and connect that. So now we have a branch in between, and we're going to have a conditional here. So what is that conditional? Well, we want to create a way to create a dead zone. So we're gonna get our special mouse position from center. So you'll see here, if you start typing in get mouse position, we have a class, we have our BPFL mouse stuff, and then we have our function. And there's one thing I forgot to do. So let's go back here to our function and select it. So we're back in our function library. We're selecting our get mouse position, and we're going to make this a pure const. Okay, and what this will do is basically you can treat it as if it were like a variable or whatever. It just returns what you want. So if you look here now, we've transformed it, and basically it just gets what we need, and we don't have to connect it to the execution pins or anything like that. So this will just get the stuff we want. Okay, so from here, basically this is going to return positive, negative numbers based on where we are offset from the center. And what we want to do is just kind of get the magnitude. We just want to know how, if we're like over a certain amount. Okay, so what I do here is I'm going to use ABS. If you type in ABS, it's the absolute value. Okay, and we want this for both of these. So Control W to duplicate it. And we want absolute value because we just want a raw number. So if we're 10 away from the center, we want to know that. If we're 100 away from the center, we want to know that. We don't care if it's negative or positive. Okay? And so now we basically have kind of our limits for X and Y. How far away do we want to be from the center before we start moving? Okay? And I came up with a few just numbers here. So I'm going to do a greater than. And I'm just going to say 50 for X. And you can change these and decide what you would like to do. And then I'm going to do another greater than here. Greater float than float. And for this one, I'm going to do, this one I have 200. Okay, so, and the reason is because of kind of how the ship turns based on where the mouse is in our UI. But you can change these to however you want. So now, if you're 50 away from the center on the X axis, you'll start moving right or left. And then if you're 200 away from the center on the Y axis, you'll start moving up and down. And we basically want if either of these happen, which is basically an OR statement. Okay, if either of these are true, then the branch is true, and we can rotate. Okay, so this is our dead zone. Okay, and you can even highlight this area and right click and create a comment. Just call it dead zone. Right. All right. So if these are true, then we'll move, and if not, it just ignores basically this input. Okay. So if we go back to our flying example now, we crashed. Woo! All right, well, let's see if we can fire this back up, see how fast it recovers. And okay, so we still have our stuff here. Always save whenever you can, right? Let's see if it worked. Okay, so now if I find the direct center of the screen, I stop moving, and you'll see if I move just a little bit to the left or right, we turn. I have to move a little bit more to go up and down. So we can change that too. So now you can see if I bring it back in, we kind of stop, which is good. Because you might not want your player to have to like find the center. But we can, so we can turn this down to 50 as well and save it, play. And now the dead zone is going to be a lot smaller, okay? So it's actually up here in the center here. And you can offset this dead zone as well if you want. But that's basically how you do it. Okay, so I hope that helps you create your own space combat sim using a Freelancer style control scheme, and we will pick this tutorial up and create some of the UI next in the next part of the series, but I feel like this piece was already long enough to kind of give you this information, and to go on to the UI, it's a whole lot more. But luckily we've created some of the things that we need already to do the UI, so it won't be super complicated. So, so just to give you another preview, kind of the finished product, and maybe while you're waiting for the next tutorial to get posted, you might want to come up with your own crosshair image with a transparent background and some sort of arrow-like thing, like what I've got here. Okay? And so hopefully you like this tutorial. Please like and subscribe to the channel. We're growing the channel. Hopefully we'll hit 1,000 subscribers sooner rather than later. So please recommend it to other folks that you know as well. And thanks for tuning in. All right.